Excellent. Okay. Welcome, everybody. This is outstanding. It's the fall semester. We're starting a new academic year. And this is the most amount of people I've seen on campus in a very long time. Now, technically, we had in-person classes, like hybrid classes last fall, last spring, but it seemed like the attendance was way, way, way down. So like, hi, it's good to see y'all in person. And hi to those of you who are also online. I want to say we have about 20 people signed up in person and about 30 people signed in online. So this class size is about 50 people. And so one of my goals is to try to go ahead and have cohesion between the online section and the in-person section. And we'll talk about how we can try to manage to do that in a couple different ways. But this is 2467. This is system programming concepts. So hopefully that's the class that you expect this to be, because that's what I'm going to be teaching. And so we're going to cover effectively slide set 0, which is going to fundamentally just be the introductory stuff, the syllabus stuff. So today is going to be the easiest of our lectures before moving forward. We're kind of going to motivate what it is this class is about, what we want to get out of this class, and what you should know by the time everything is said and done. So at any time, if you have any questions, if you're online, go ahead and let me know inside of the chat. I have that available right here on my display. And if you have a question in person, just like kind of get my attention. And now if someone does actually ask a question and you see it and I'm kind of in my zone, let me know. Oh, yeah. There. Oh, no, that's okay. Okay, so let's move on. We've established what class we're in. Let's establish who the instructor is. So I'm a surprise instructor, right? So I'm Ted Holmberg. My primary role in the department is as the industry liaison. So what I do in that capacity is usually communicate and talk with a lot of our industry partners to find out what skill sets they want you to have by the time you come out of this curriculum to make you employable. So a lot of the technologies that we adopt in the classroom, a lot of the tools, a lot of the concepts that might motivate selecting one language over another or one framework over another is due to an ongoing communication, like an agile development process between us and the local and regional and even international industries that are looking to hire you out. And so in addition to being an industry liaison, I also serve in the capacity as one of the faculty staff advisors for a lot of the student organizations. One of our big drivers that we would like to see this semester is to resurrect the ACM, the Association for Computing Machinery. That is the professional organization for computer science. And they have academic chapters located at all the major universities that have CS programs. Our chapter kind of went defunct around COVID time. And now that we have people in person, I would love to get an active chapter up and running, because it ends up supporting all of you. It's the people that benefit most from student organizations are the students, because it allows you to do something fun outside of all the study, the grind, the homework, things like that. So if you are at all interested in joining the ACM, either as a member or as a leader, as someone who can help manage and plan out meetings and talk about what you want from that club, please either message me on Discord, I'm Ted Holmberg, or go ahead and or meet me after class. But I'm certainly looking for some good student leaders to get the ACM up and running. Okay, so besides being a staff advisor and besides being the industry liaison, another role that I do with the department is an instructor. I've taught 1583, I've taught 2120, I teach the advanced web applications class, I've taught, let me see, there's the C++ class, I helped develop the intro to cybersecurity class. This is my first opportunity to teach this in programming concepts. So just like this is the start of a journey for you, it's the start of a journey for me. So I'm super excited to teach this class and walk this path with all of you. Okay, so with that said, that's a little bit about me. I do have an office on campus. It's at 347, right? I think I'm going to make my office hours before lecture, but I'm very flexible. So if I'm in my office and the door's open, you're almost always welcome to come in and stop in and say hello. But I'm going to reserve Tuesdays and Thursdays from 2 to 5 as my actual office hours. But another thing that I'll do, and we'll talk about this as we kind of progress through the slides today, is I'll have a dedicated Discord server just for this class so we can have class discussions. And I'm really going to recommend that we can kind of have the ability to bring our face-to-face group and our digital group, our cyber group, together. Discord server. All 50 students who are part of this to share ideas. Design curriculum. Can everyone hear me again? Okay, perfect. Where's that pop up? I want to pop up the messages. Of course, when it relaunches, chat, can I? Oh, well, it is what it is. And here we go. Go here, can I hide? Oh, is it because, oh, whatever, I don't care. We'll shove this in the corner outside. Okay. Now, what I was saying was I reserve the right to change things. Like, for instance, one of the ways that a lot of your the projects, the labs for this class are designed are on a individual basis. But I'm contemplating potentially making those pair-based or whatnot. So I want to take a look and actually work through the labs this week myself. And based off of what I go through, I might select to make those more group oriented, because I think there's something to be said in terms of learning by working alongside someone else and not just being forced to work on things in isolation. I don't think actually that's the greatest environment to learn something in. So I reserve that right to go ahead and change what's on the syllabus. Nothing's set in stone here. I never like to set myself in stone. I just like to use this as a guideline. And so I want you to know I'm using that as a guideline as well. Okay. Anyway, with that said, I have an email address. There's a Discord server that I have set up just for this class. I'll share a link with that inside of this chat, and then I'll actually share it with all of you as well through email after the class is done, so that you don't have to get online to be able to do that. And then also, there's a departmental Discord that I advocate everyone to become a part of, and that'll allow you, again, to be able to more cohesively communicate, not just with the people who are sitting next to you, but to also communicate with those people who are our cyber students who exist in the ether. Yeah, there are alumni on there. There's some instructors are on there. There's actually a decent amount of chat that happens on there. And hopefully, now that we have more people on campus, we can start doing more things up here on the third floor as well. So again, if you're interested in student organization stuff, either whether it's through a cyber environment or a actual in-person environment, please let me know. Okay, moving forward. So a quick overview of the what we're going to cover today. Effectively, it's going to be in this the syllabus talk, right? Keep it nice and leisurely on the first day. So I'm going to open up the welcome. Already did that. We'll talk about the motivations, about what drives us to want to sit here for 16 weeks, 3 hours a week, talking about system programming concepts. We'll talk about, well, then what are the course objectives? What are the prereqs for this course? What are you going to get from it? Then we'll talk about the workload. Another thing you're probably going to be concerned about. What are you going to have to do in the course? And then we'll talk about what readings you should be expected to have in order to be able to do the workload. And then finally, the metrics. How are you going to be evaluated? How are you going to be graded? I think that's usually what you care about on the first day. Okay, so let's move on to the course objective. So this course is going to be an introduction to system programming, right? So if you want to think about the computer science curriculum, typically you could think of as being a sequence of 5 core classes. Once you've gone through those 5 core classes, your schedule opens up and you can almost take any other class inside of the curriculum. So the first class you have to take is 1583, right? That's Software Design 1. The entire point of Software Design 1, which you're taught in Java, right? A nice high-level language, is to make sure everyone's on the same page for 2120. Right. One of the challenging things about an introductory course is you might have someone who has 30 years of development and they're coming to get a degree, or maybe they have dozens of years of experience just programming as a child. And then we have some people who come into the curriculum and they've never looked at code before. Right. So 1583 brings everyone up to one level. And then that's 2120. That's Software Design 2. Where you start to learn how to use the tooling, you start to learn how to start designing and implementing code using, hopefully, industry level standards, right? So you start learning how to use an IDE, you start learning how to go ahead and do like test-driven design, use auto documentation, right? Read APIs, produce code that is APIs. Once you get out of Software Design 2, you go into data structures, which goes into the concept. It goes into concepts about algorithmic efficiency. It goes into what drives your ability to determine and decide whether code is implemented well or whether it's implemented poorly or implemented better. And then you'll look at various data structures and different searching and sorting algorithms and whatnot like that for that. And then after that, you have assembly, right? Which is very low level programming. And then finally, the system programming concept. So if you want to think about this, this is like the very tail end of the intro sequence. System programming concepts should set you up for success in both OS, right? So the concepts we're going to cover here, you're going to need to know for operating systems. Not just operating systems, though, it also should set you up semi-successfully for networking, although not so much networking as OS. OS is going to be the big one that really tails after this one, conception. But I think after 2125, you're free to take whatever you want. Anyway, a little bit of a diversion. This course is an introduction to system programming. Specifically, this is probably known for the course that you learn how to program in C. So we're going to use C and we're going to use the Unix environment. In fact, we already have a dev environment that's set up for you. You're free to use your own machines. You're free to install whatever software you need for your own machines. But we also have a guacamole instance, a web terminal that you can go ahead and access right through the browser that should have all that you need for this course in for you. Okay. With that said, students in this course will become stronger computer scientists by mastering the basic concepts underlining all computer systems. So you see that on the next slide. So I'm not going to give it away. I'm going to wait until I hit that slide. But I'll also just say the point of this is that you're going to learn what happens underneath the hood, right? So when our programs run, we haven't been concerned about what makes them run, right? So like when you're in Java, you install the JVM, you're using, you probably use a couple of command line calls, right? So you make a call to the JVM and the JDK, right? To go ahead and compile your Java code, to run your Java code. Now, okay, let me see. The chat here. Thank you so much. Let's minimize that for now. Well, so software design, so this class isn't going to be so much of software classes. And
oh, yeah.
okay, let me make sure I'm not muted. Perfect. Okay. So this course is so software design 1 and 2 and some levels data structures is going to be more in line with high level concepts that drive architecture, that design that guide you towards optimizing towards clean, literate, and shareable code that's flexible, code that's maintainable, code that's reusable, right? And not to say that's not important where we're going to be at in this class, but that's not going to be a concern. That's a concern for another class. Our high level code, when we're using these abstractions that high level languages such as Java or C++, or in many ways C, we'll see what's afforded to us, what happens in order to get it to run on an actual computer system, right? So up until now, we've been able to kind of ignore that, at least from the perspective of Java 1 and Java 2. Now, we weren't able to ignore that in assembly. In assembly, the hardware was in your face. There was no escaping it, right? In assembly, you had to worry about your registers, right? You had to worry about what was pushed into and out of the stack and what your instruction pointer, where your instruction pointer was at any time. And knowing how much data was consumed inside of your various register spaces, how much is our data formatting actually taking of our register space, of our bytes, that are addressable bytes that we have access to. So you have these like low-level concerns, which is assembly. You have these high-level concerns, which is Java 1 and Java 2. Here, this is going to be the nexus point. And that's how we're going to use C effectively. The joining between the low-level world and the high-level world, which is going to segue us nicely into, again, operating systems, which is likely going to be the next class or one of the follow-up classes you'll have to this one. Okay. So with that said, let me see if I can't move to another slide before I drop my Zoom again. So with that stated, the prereqs for this, now knowing one of the motivations behind this class, is going to be 2120, so that you have sufficient understanding of high-level language and the concerns that go into programming at a high level, and then also 2450, which is your assembly language, so that you understand the hardware level, the low-level concerns about what actually happens when your applications run. Oh. So that must mean that it stopped sharing then. Okay. So wait, now that I have my pop-out, where is, close that. Where'd my,
Minimize.
yeah, oh, yes, I did. There we go.
Where it says his name.
Oh, here,
Yeah, hit the other button, other one.
right here. There we go. Close, I'll minimize that again. Okay, let's see here. Yep, share screen. Okay, can everyone see that now? Okay, perfect. Okay, so we talked about software design 2, we talked about assembly, and pretty much the remaining portion of this slide is just saying what I had already said on the last slide. We're going to take what you've taken from those two classes and we're going to show how they merge into what's going to drive system programming concepts. So everyone should have taken these two classes. That's the you anticipate you getting out of this class, right? We talked about what you needed to know before you start the process. Right? Well, that one to look at even more practice at this data representation. We're going to acquire knowledge on how C programs become machine instruments. So when C programs understand C is a high-level language. So the C concepts are to compiled into code, into machine code is not going to be, it's going to be similar to other languages. Now, one advantage of C is it actually does get compiled down into machine level instructions. Java, as you might be aware, is kind of special in the fact that you're creating bytecode that runs to the JVM. So even though you compile your Java code. It doesn't ever actually turn into machine level instructions. It converts into code that can run under the JVM. And then Oracle is responsible for ensuring that the JVM runs on almost any platform. And so that's why Java is incredibly portable. If you can get your code to compile bytecode to run on the JVM, anything that has a JVM, it can also run on. Whereas with C, we can actually go all the way down to effectively the bare metal, which can be dangerous. But that's one of the intents of this class, right? Like the idea is you can program your OS in C. That's how to the metal it can get. So we care about that. We want to learn about that. We want to experience that. We're going to learn how running programs really works with the function call stack. It's going to be a big driver. We're trying to up space that's going to lead you success systems. You'll learn about the exceptional control flow, so signals and process control. And in fact, we'll actually have a lab where you'll see on the next slide where you actually get to build a simplified version of your own shell. And then finally, you'll learn how programs interact with the operating system. So this is what you should now, despite just the concepts, let's talk about the skills you're going to develop throughout this class. You'll learn how to use the Unix command line, which you probably already have some familiarity with, right? Just like, what were y'all using? You use the terminal app if you're on Mac OS. You probably use terminal if you're using a Linux. How many of y'all are on Windows when you were going through Java 1, 2, or whatnot? Okay, and what's what's you okay, share screen. I like how it just undoes all my settings every time it comes back too. Okay. So here we go. Can everyone see my, yeah, the lecture will be uploaded, although I'm really interested to see how disjointed it will be. Okay, so everyone can see my screen. Okay. So as I was just saying earlier, the skills we're going to develop, you're going to learn, you're going to become much more familiar with the Unix command line. We're going to look at C as it relates to being a system level programming language. We'll learn how to effectively use a debugger. And in particular, we'll use GDB. We'll learn how to execute a buffer overflow to inject code, right? So again, we'll start motivating some of these cybersecurity concerns when we, as it relates to how our program executes on our system. And then we'll also really develop the ability to master our process control by writing our own shell. So how are you going to develop these skills? Through lab work. There's going to be a total of 5 different labs over the course of the semester. Some labs are going to be easier than others. These labs come from Carnegie Mellon, the actual material that they've authored. So these are, I think, really, really well put together, well thought out assignments that will get you from some 0 to where you need to be. So the first one's going to be the easy one. That's the introductory lab, basic C programming stuff. We're going to do that one. We're going to talk about that. We'll go through that next class. That's probably what we're going to do next lecture, the introduction lab. We're also going to use probably you're familiar with this with 1583. We'll use AutoLab as a submission tool. It won't be the same type of submissions that we were doing in 1583, but the lab works will all be designed that you can go ahead and as soon as you submit, you'll get feedback on what your score is, and you can submit an unlimited number of times, right? So the driving concept on you always knowing what your grade is going to be how it is in this course as well. And then the next course is going to be the data lab. That's where you're going to try to go ahead and not just understand low-level representations of data, but how you'll be tasked with riddle-like problems where you're limited to the number of instructions you have to go ahead and transform your data in very specific ways. And again, as we get there, we'll talk more about the labs. We'll have a bomb lab where you'll use a debugger, right, to try to prevent the bomb from going off. So this will go ahead and build up your ability to use a debugger. You'll have the attack lab, which is going to be the one where we'll go ahead and try to do a buffer overflow. And then finally, we'll have the shell lab where you'll go ahead and build your own simple shell that will go ahead and allow you to see how an application effectively runs on your system. So by the time we get through all these labs, that's going to be the practical work that should get you through this class. Now, I'm not going to lie. This class was designed to be a lot of work, but there's a lot to learn from here. There's a lot of concepts. There's a lot of applications that are important to learn. If you want to really master the craft that you're going into as a computer scientist, as a software engineer, or these are concepts that are going to drive your foundational understanding if you want to go into cybersecurity. So be prepared to invest a lot of time in the coursework. Like the textbook for this class is very well written. I encourage, and I haven't showed you what it is. It's in a syllabus. It's in a future slide. I'm just saying this now, since we're talking about classwork, read the text. Go home, start reading it today. Because it's a very approachable way that's going to set you up for success. So don't just bank on me giving you the highlights of what is inside the textbook. Okay.
So is that book is it less dense than the data management, data structures, I should say. Data structures was very, very dense.
Okay, so yeah, that's a really good question. And let me make sure everyone can still hear me when it clipped out. I'm assuming you can. Okay. So I was asked the question, is this book less dense than the data structures book? If I had to imagine, was the algorithms book was the data structures book? Do you remember the name by? If it's the book that is usually the canonical data structures book, that is renowned for being dense, where it's compacted as much technical and academic knowledge with the driving concept being to ensure precision, accuracy. And so those types of textbooks I think of as what are, in my own mind, as instructor-like textbooks, where that text is meant for an instructor to ingest, break apart, and then disseminate to students. And those textbooks have value, the fact that they're written in a way for accuracy. They don't depend on analogy or kind of bringing the material down, because by encoding it in such a way, they know for a fact that everything is on the level. But it makes for a very difficult read coming from a student perspective. I would say this textbook is almost like one that could be a student-read textbook. So I would compare it probably more to the Dytel and Dytel How to Program book, where that one you could read at a student level and go through, and it makes a lot of sense. Or did you use Kip Irvine's book for the assembly class? Yeah, so I compare it to that as well. So that's a good question. Yeah, usually the data structures text, it's the canonical one too. It's the one that's really popular, but because of the subject matter, data structure is almost like a subdomain in mathematics. It's written almost like a math textbook. Okay. Now, where did I leave off here? So, oh yeah, so pretty much this slide is just saying it's going to be a lot of work, but it's worth the work. It's worth the time investment. I'm just letting you know, day one, that you're going to want to start spending time. And the first way you do that, actually, we have a slide on, okay, we have syllabus. I don't care about this. Okay, this is the book. And so this book you're going to want to use because the labs are actually designed by the authors of this book. So if you need help solving the labs, that's what the book is also intended for, right? It gives you all the information you need to do the assigned work in this class. It'll give you practice problems that you can go ahead and check your competency of the material. Our exam problems are going to come from this book, right? It's a good book that's worth keeping. I guarantee you, if you go and probably ask any one of the professors, and I'll even restrict it into a subdomain, go ask any of the professors inside, the recent ones at least, who are inside the cybersecurity domain. I bet you this is a textbook they used when they were going through their undergraduate program. Okay, you should have access to these books through Follett, right? I haven't actually used that before, but my understanding is you pay student fees that give you access to this content. So everyone should have access unless you decided not to use Follett, in which case you should go buy the book. Okay, optional textbooks that are worth reading. Like I said, this class is informally also referred to or known as like the C class, the class where you get exposure and you learn how to use the C programming language. So with that said, you should get this book, the C programming language. It's not required, but this is a classic book, commonly referred to as K&R from the two authors who had penned it. And so this is the authoritative standard. So written by the creators of C and the Unix environment. Yeah, it is. If you are serious about computer science, and I'm probably guessing all of you are, if you're this deep into the curriculum, right? You've already survived enough classes that you should start picking up the quintessential text. This would be like if you were like going through a English history class and not having something like Chaucer or something like Shakespeare on your shelf, right? Like this is a quintessential text. Now it's not required, but you should get it. And now there's also two initial readings that I want everyone that I'm actually making required, but they're free. So you have the Essential C, and you have Unix programming tools. So I want everyone to go to these links and download those PDFs and read through those as well. Okay, so how to succeed in this course. I think I already alluded to this, and I think it's pretty obvious, But, well, you want to attend class, right? We'll have 2 lectures per week, and we're probably going to do a combination of lectures and maybe interactive labs where we kind of do some of the lab in person or do a little bit of debugging, right? So I do kind of like being a little practical, but we also have to make sure that we stay on pace with all the concepts. So I'll leave it up to, or what I might also do is have it set up so that we can spend part of our lecture hour where you're working along inside of a group on the labs as well. So, but the point is just attend classes, right? Like number 1 point of success is to be here. Read the textbook. The textbook is great. Try to read the textbook before we have lectures. It'll be more meaningful if what I'm talking about is the second time you're hearing about it. The first time you could read the textbook, kind of understand it, but then when I talk about it again, you can recall what you read, then it's going to make a lot more sense. Obviously, you want to complete the laboratory assignments. The assignments are designed in a way to push the theory into application, into being a practical thing you actually do. So to actually know something, in my opinion, you not only have to like have a understanding of it, but you have to understand how to use it, right? And so the labs are where you actually put into practice what we talk about. And then finally, you need to take exams. There's 2 of them. We'll talk about that. So as of now, the way that this class is structured is half of your grade comes from assignments, which are the labs I showed you, right? They're going to be the 5 labs, and half of your grade is going to come from exams. One of your exams will be a midterm. The other exam is going to be a final. So, and those are weighted equally. So 25. So you can think of each exam being worth approximately 25% of your grade. And again, I'm going to take liberties on how I want to do my exams, right? So I have, there's example exams that both the textbook provides me and I could use from this curriculum, but I'm not going to say right now definitively that I'm going to do the exams the same way as they were given before. So I'm going to think about this. I'm going to look at it and I'm going to get back to you on how to prepare for those exams. Okay. The final though is scheduled for Thursday, December 7th from 5:30 to 7:30. So just so you know when the final exam is scheduled for. So in terms of where can you go to actually do the work? Again, all of the assignments, there should be no reason why you can't get A's on these, right? Because you submit them to AutoLab and AutoLab gets you a grade. They are going to be difficult though. They are a lot of work, but you'll instantly know what you get whenever you do your submission on them. Now, you can do your submissions almost anywhere. You can do your lab work almost anywhere. Like you can use this lab if it's available. You can use the labs downstairs, 209 or 212. They all attach to the thin clients. They all have thin clients that talk to our data center that give you access to the workspace that's already pre-configured. You could download yeah. Let me type this. Yes. Have a section to get me there. Okay, well, okay, so here are, if I go to student read, there we go. Okay, what I was just showing the class before is you can always get to the web terminal right here inside the student resources section. In fact, you could say there's also Auto Lab and a lot of other tools here right inside the student resources section. So if you haven't seen this kind of sub page on side of our departmental page, something for you to be aware of in terms of some of the resources, the online resources that you have available to you. Okay, and now let me go back here. So I was just telling the face-to-face class, so I'll extend this to the cyber class as well. If you feel lost, then ask questions in class. That's why we meet for approximately 3 hours a week, right? It's not just that though. Like I said, I'm going to set up a Discord server exclusively for this class to foster class discussions. I'm all about outsourcing the communications about the material to just not me to student, but student to student. I think peer-led instruction is great, not just for people who have questions to be able to get feedback quicker, to get their questions answered quicker, but it also allows other students who don't realize they have questions to get answers that they haven't come across yet. And it also allows students who are attempting to answer questions to really think and metabolize the content to formulate an answer. So there's just so much to be said in terms of encouraging students to talk to other students about the subject matter. I think Discord is a great place for us to bridge the face-to-face space and the cyberspace, especially in a way that's available to students 24/7. So by all means, I would prefer for you to ask any question related to the material inside our Discord server so everyone can take advantage of it. Okay, let's see here. Besides that, we're going to have our first lab assignment. I'm going to give more details about that next lecture on Thursday, and I'll adjust the due date based off of what we end up covering and talking about. But our first lab assignment is really just going to introduce C, the programming language, and Unix as our environment that we're going to operate with that. And so I'm going to not necessarily, I'm going to have a tentative due date of August 22nd for that. But again, I'm going to be flexible to see how everything kind of fleshes out. Now, with that said, I knew that we'd have a little bit of spare time. One thing that I think would be great for us all would be able to then do introductions with each other, just quick introductions with everybody, just to find out who we all are, right? So I've been able to introduce myself, and so I'll invite, actually now let me end the screen share, and what I'll do is I'll have, we'll start with the in-class people. I'll invite each person to kind of come up and give maybe just a quick moment to say who you are, how far you in the curriculum, and kind of what you're looking to get out of the course. And then we'll go to our digital people who can do the same thing. And then once we have all introduced ourselves to each other, then we'll say goodbye to the very first lecture of this semester. So let me stop my screen share so that we can actually go back to having perfect. Okay, so